This next quick little lesson is really not a lesson at all. It's a prep for the quiz, just so that you review quickly lessons 12.1 to 12.3 before you take the quiz. And I'm giving you examples of the kinds of questions that we're asking. So number 1 to number 3, I'll ask, is it inverse variation, direct variation, or neither? This is essentially what we did in 12.1. So is it inverse variation, direct variation, or neither? Well, if you remember, inverse variation looked like this once you put everything equal to x, right, with x in the denominator. Direct variation looks like this with x in the numerator, and neither is usually because you have a value of some kind added, and that can't be a direct variation because by definition, direct or inverse variation has to, direct variation has to go through the origin. Inverse variation, of course, looks like this. Just to review what these look like when they're graphed, right? This looks like there's your rational function. This is just a line through the origin, and neither means it's a line, right? But it's not a line through the origin. It has another y-intercept somewhere. All right, so sample problem would be 2xy equals 1, and you're being asked, is it inverse, direct variation, or neither? Well, to do that, you have to set it in y equals form. So we're going to divide both sides by 2x to make that happen, and we end up with 1 divided by 2x. Clearly here you can see x is in the denominator, and therefore this is going to be named inverse variation because that is the type of function it is. All right, so that's numbers 1 through 3. Let's look at 4 through 6. 4 through 6 ask you the question, are asking you two questions. They're telling you, first of all, this is an inverse variation, and given that it's inverse variation, what is the equation, the inverse variation equation? And 2, what is y when x equals 3? It is very easy to accidentally solve one and then forget to solve the second part of this question, so make sure you don't forget. Here's an example. If x equals 6 and y equals 4, and we're told that we're talking about an inverse variation kind of equation, so we know that the governing equation is y equals a over x, then we will use x and y to solve for a. 4 equals a over 6. My dryer is always going when I'm doing these lessons, apparently, and I get a value of a equals 10. So once I have my a value, I can go back and answer the first question. What's the inverse variation equation? It is y equals 10, sorry, not 10, 24. I'm multiplying, not adding. Don't know why I did that, except that I was distracted by the dryer. 24 divided by x. Okay, but then I have to answer my second question, right? So that was the first question. My second question says, what is y when x is 3? Well, clearly, if I put in a 3 here, if x equals 3, then my y is going to equal 8. Okay, make sure you answer both questions. That covers through number 6, and we're going to go through quickly numbers 7 through 9. Numbers 7 through 9 are graphing, And you've graphed like this before, and I'll take one graph, for example, y equals -2 over x minus 6. So if I'm graphing this, I can see right away that it's going to be shifted, right? 6 units to the right. I can see the negative number is going to tell me that's going to be a reflection, and the 2 tells me it's going to be a stretch. Again, here you're being asked 2 things. You're graphing, and don't forget the second question, domain and range. Because I grade you with 3 points on this one, so it's a third, a third, a third. Graph, domain, range are each a third, okay? So as I graph, I know that this has to be, let's see, I'll draw my graph down here. It's going to be shifted to the right, so I don't have to draw quite so much in that second quadrant. Draw it like that. Okay. Not the neatest graph in the world. Okay. And I'm going to go, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, and -1, -2, -3, -4. Okay, so I now have prepared my graph. And I'm going to go get my values. And when I graph it, I think I'll do it in red so it stands out just a bit more. So let's see, if x is, let's see, we'll try 0, because 0 is allowed here. If x is 0, 0 minus 6 is -6, -2 divided by -6 is +1/3. So I get 0, 1/3. And by the way, ooh, I should do my first step, which is really drawing my asymptotes. I know one of them is just here. It's my x-axis, but the second one, 2, 3, 4, 5, 6, is here. It's moving my graph sideways. So I know that my graph is going to be here and here. And it's going to be, sorry, here and here because it's a reflection. So that is why when I put 0, 1/3, that makes sense. It's going to be through here. All right, so I'm going to put in, let's see, we'll try a 2. 2 minus 6 is -4. -2 over -4 is 1/2. So 2, 1/2. Slightly higher here. Let me put in 4. If I put in 4 minus 6, I get -2. -2 divided by -2 is 1. So 4, 1. I'll just try one more. What happens if I put in 5? 5 minus 6 is -1. -2 divided by -1 is 2. So I'm going to be here, and I can see my branch. Sorry, second buzzer. Going up this way. I need to do my second branch down here, so I'm going to have to come up with my other numbers. And so I'm probably, let's see, I'll start with number 7 down here. 7 minus 6 in the denominator is 1. -2 divided by 1 is -2. So 7, -2, and that makes perfect sense if I look at this graph. Let me try 8. 8 minus 6 is 2 in the denominator. -2 divided by +2 is -1. Excuse me. And let me try, let's see. Let me try 10 and see what happens. 10 minus 6, I get +4. -2 over +4 is -1/2. So 7, 8, 9, 10, -1/2. And here is my second branch. Now, when this takes a long time, it is so easy to forget step 2. this has taken me a while and I did a good job, I've got my graph, you've got to remember step 2. Step 2 is finding your domain and range. Well, what is my domain? Well, okay, my x values can be any number except 6. So my domain, and I'll put it in red, is all real numbers except 6, right? That's an accurate definition. And my range, you can see, is y can be above 0, 1 can be below 0, but not 0. So my range is all real non-zero numbers. In other words, all numbers except 0. And that's it. And by doing that, you're really just saying what your asymptotes are. Okay, so that takes care of 7, 8, and 9. And the last part for the quiz prep is numbers 10, 11, and 12. And if you were looking at the quiz in the book, those are added on because I decided to make this a 12.1 to a 12.3 quiz instead of just a through 12.2. So these are just going to be polynomial divisions. So as an example of what I would be giving you, I'll be saying, can you divide a squared plus 3a minus 4 divided by a plus 1? In this situation, you're just going to do what you've been doing before. If for any reason this said a squared minus 4 plus 3a, you have to make sure to put everything in descending degree. Same with this. If this is 1 plus a, you'd have to reverse it. If there's a missing term, say it said a squared minus 4, you'd have to make sure that you add 0a. Okay, this is really important. Okay, so here, a squared plus 3a minus 4 divided by a plus 1. How many times is a going into a squared? Or you can also say a times what is a squared? Well, a times a is a squared. So a times, and once I've done that, I'm going to put a times a plus 1 over here just to remind myself of my first step. And I get a squared plus a, and I'm going to subtract that, which means I'm changing my signs from a squared plus 3a. When I do that, here I get 0, and I'm left with 3a minus a, which is 2a, and I bring down my negative 4. Then I look back up here, what times a will give me 2a, or how many times does a go into 2a? Well, clearly if I put 2 times a will give me 2a, but I multiply by both a plus 1, by a and 1. So what I'm really doing is 2 times a plus 1. When I do that, I'm going to get 2 times a is 2a, and 2 times 2 is 2. Sorry for my dryer. We're going to change the signs because we're subtracting, and we end up with a remainder of minus 6. Well, that remainder ends up being put up here with my answer, so I get minus 6 over a plus 1. Okay, so I've now given you one example of each of the kinds of problems that I'm giving you on the quiz. Good luck with it. Take your time. We're getting at the end, so you really want to go slow. You can always see, you know, if you've done it right. Just literally, if you're not sure, cover this up, do a separate piece of paper, see if you come up with the same answer twice. It'll give you a good idea if what you're doing is correct. So again, before I leave you, going back over the quiz prep, numbers 1 through 3, we're looking for, is it inverse, direct, or inverse variation, direct variation, or neither? 4 through 6, you're looking for 2 answers. Is it what is the equation? And so you're going to use x and y to come up with the equation. And what is y when x is 3? You're going to use the equation you came up with, plug in 3 for x, and come up with your y. Number 7, 8, 9, you're doing two things. First, you're graphing, and you're coming up with your rational function on a graph. Number 2, you have to state your domain and your range. Do not forget to do that. Finally, when you do 10 through 12, you're just going to divide your polynomials. Okay, good luck.